Hey everyone, I want to talk to you about outliers today. So let me get that mic closer to my mouth. So an outlier is, well, there's a lot to say about them, but first let me give you the sort of the technical definition of what outliers are. So a vague-ish definition is that an outlier is any data point that's much different than the other data points in your set. So much different can mean a variety of things. For us, mostly it means some number that's far away from the other numbers within that one data set. And so what we need to do is precisely define what far away means. And so we've got a couple ways to do that. So let's talk about those first, and then I'll go back a little bit and talk about sort of some examples of outliers and what to do with them. So here is a data set. I've got each of these blue dots is a data point, and we want to talk about which ones might be outliers. So depending on what definition you are using for outlier, there could be a couple different outliers here. So most likely, this data point right here would be an outlier, and probably this one too. Those are pretty far away from the other data points. That's how you can tell. Now, it could be the case that some of these down here might be outliers as well. Not really sure. I didn't put a real scale on this, but that's what I mean when I say much different than other data points, right? They're different in this case, in some quantitative way. And if you're dealing with qualitative data, you have to kind of figure out what outlier means. But that's the basic idea. When you get data points that are far away from the other data points or far away from what you expected to see for some reason, those are the things that are outliers. So let's see what the specific, precise definition is, or rather, there's two of them. I'm going to use the second one. If you read your book, they like this one, and I don't know why. This is a more complicated definition than we need, but I'll explain it anyway because I don't know, maybe one of your future stats teachers uses this. When your book talks about outliers, this is what they're going to mean. I'm going to show you what I mean by outliers in just a minute. So this is called the 1.5 times IQR method for finding outliers. And if you remember, IQR is interquartile range, or the difference between Q1 and Q3. So it is so Q1 to Q3 is a distance, right? Q1 is some number, Q3 is some other number, and the distance between those numbers is the interquartile range, or IQR. The way we classify outliers using the 1.5 IQR method is we find that distance, we multiply it by 1.5, and then we go that far below Q1 and above Q3, and those borders out there that you can't see on my camera are called the inner fences. Anything outside of that is considered an outlier. If you're wondering about the phrase inner fences as opposed to just fences, there are outer fences as well, which is 3 times IQR away. Now, I understand that was very confusing, so let's see a picture. I personally think a lot better in pictures than I do in words, so I use gestures a lot. So let's say I have my data. So these are the quartiles, right? So here's my median, here's my first quartile, my third quartile, my minimum, and my maximum. Right? This is called the box plot. You might want to check out the box plot video if you haven't watched it yet. So picture a bunch of dots in here where this is the median, and this is the lowest dot, the highest dot is right here, and then the data is mostly in between here and here. So the interquartile range is the difference between Q1 and Q3. So it is this distance right here. Goes from Q1 to Q3. So it's that long. That's how long the IQR is. It's the length of the box in the box plot. So the first thing we do is we take that distance and we lengthen it to be 1.5 times as long. And then we add that on to Q3. So I'm going to take this distance and go that far above Q3. So up here, let's see here, how long is that? That's like over here. And then same distance over here, which is like that far-ish. I'm obviously estimating this pretty badly, but that's okay. I think you get the idea. So These are the inner fences. Inner fence. This is also an inner fence. So you might notice that the minimum and maximum are here, right? The maximum is here and the minimum is here. So that means that all the data values fall in this range here. And so there's nothing that's outside either fence, right? There's nothing outside the left inner fence or the right inner fence. So this data set has no outliers. And in general, you can kind of tell by looking at the box plot, the middle 50% is in the box here. So that's where the bulk of your data usually is. And then there's only then it only goes up this far. So none of the data is all that far from the middle 50%. So everything is pretty clustered around the middle. And so there's no outliers here. Right, I hope that's reasonably clear from my scribbling. Let's see what more there is. So here we have a smaller box. I've color coded the same thing. So this is Q1, Q3, the median, the IQR is the length of the box, and then 1.5 times the IQR is a little bit bigger than that. And so we take the 1.5 times the IQR and add it on to Q3, so it goes this far, and subtract it off of Q1, so it goes this far. And then those borders are the inner fences. And in this case, you can see that there are indeed some outliers here. That all this stuff, anything over here or over here are outliers. Outliers. I don't know why. I shouldn't have done that in pink. Let's do it. Oh no. Oh no, I hope I haven't ruined it. No, I haven't ruined it. Good. I don't want to use the same color here. So all these are outliers. And all these are outliers. Outliers. They're outliers because they lie outside the inner fences. There you go. That's how you can tell. All right. Let's see the method I would actually prefer to use, which is this one. 2S. So find 2S. S here, sample standard deviation. Hope you guys remember that symbol. So find 2S. It's a number. Remember, standard deviation is a distance again. And then any point further away from the mean, the sample mean, than 2S is considered an outlier. That's it. Much easier to use than the 1.5 IQR method. I don't know why. So they don't give you exactly the same points being outliers, but pretty close. Generally, if a point is an outlier in one method, it's probably an outlier in the other method too, and vice versa. Not 100%, right? They're different methods, so you get slightly different points, but they're pretty similar. The reason that this method is preferable, in my opinion, well, there's two reasons. One, simplicity. You don't have to remember a bunch of, like, okay, first I find this number, then I lengthen it, and then I go somewhere from, then I use that distance to go above Q3 and below Q1, and then I check to see if there's anything outside there to see if there's outliers, right? Like, that's kind of a longish process. It's more complicated than it needs to be. Also, a thing that you'll find later on is that two standard deviations, so remember, a standard deviation is a distance. Two standard deviations turns out to be a really standard measure, a really normal measure that we use to determine if things are unusual. And so we might as well start doing that now. So in general, anything more than 2S from X bar is an outlier. This is the definition I would actually like to use, and so this is the one we're going to use. We will use this definition for a couple of things, and then when we get to chapter, well, I don't remember what chapter it is in the book, when we start doing linear regression, this becomes very relevant. And strangely enough, your book uses the 1.5 IQR method for the entirety of the book, then gets to regression and switches to 2S. I don't know why. I don't know why, but they do. And so, yeah, so we're just going to do 2S from the beginning. So any point that is more than 2S away from the sample mean is an outlier. There you go. That's our definition. Okay. Yeah. So here is the interesting question. What do you do with outliers? So firstly, I need to give you a couple of examples of things that are outliers. So I guess not firstly. Firstly, I want to make the point that what to do with outliers is there is no one answer. It is entirely context dependent every single time. If you get a weird value, the first thing you want to do, I guess this is always true. The first thing you want to do is investigate why you got that value. Was it just a strange thing that happened and might happen again if you were to measure this data again? You probably want to leave that in. Is it some measurement error? You probably want to throw that out. So let me give you a couple of examples. I don't know how many of you have actually been on campus at SBCC. That's a strange thing to say considering you attend SBCC, but if you have not been on campus, let me explain about the Math Lab. The Math Lab is a wonderful place. It is on the bottom floor of the interdisciplinary building. If you ever want to go there, that's a great place to go learn math. They have wonderful tutors. I used to go there all the time. I would basically just hang out there whenever I wasn't teaching and help students who were there to learn. So I am friends with the women who run the Math Lab. And one of the things that I got from them is I got the data, I got the login data for every day in a semester, because they keep track of that. The people who to go into the Math Lab, you like log in on the computer. And I just wanted some data that my students could relate to, basically, that we could use to do projects with. And so we were using that data. And if you look through the data, you'd see that Monday, Tuesday, Wednesday, Thursday, you'd get 150 to 250 people coming into the Math Lab in a day. Like, they're open for like 8 hours. And over those 8 hours, you get about 150 to 250 people logging in. On Fridays, they're not open as long, and so you'd get fewer, 50 or 60 people or whatever. And then at one point in the data, there was like a Wednesday or Thursday that had like 60 people. And so I asked Allison, who runs the Math Lab, or is one of the women who run the Math Lab, whoa, why is this so different? And she told me, well, that day the login computers broke. And we couldn't have people log in, so they just they broke around lunch. And so we got this data point that is very different than all the other, let's say, Wednesdays like it, right? All the Wednesdays have 200 to 250 people. This one Wednesday has 60 people, and you think, well, that's a much different number. Well, that's an outlier. What do you do with that outlier? We throw it out, because what you're trying to check is how many people came to the Math Lab that day. It was more than that many, because the logging computers broke, so we weren't counting right? That's a measurement error. So we just throw that outlier, or throw that one out, because it's not relevant to what we're doing. An example of when you might want to leave an outlier in. So let's say you are you're doing a survey of incomes in Santa Barbara County, and you randomly mail out the survey, or probably call people who live in Santa Barbara County, find out how much money they make. Right? This is not a great survey, but let's just go with this one for a second. Right? The people you call live in Santa Maria, and they live in Guadalupe, and they live in San Ynez, and Santa Barbara, and Montecito, and Goleta. Right? All these places that you're calling around to, and you get a lot of like $50,000 a year, $75,000 a year, $150,000 a year. And one person you call answers that they made $3 million last year, right? You got someone in Montecito who's very wealthy. This is going to be an outlier. This is going to be significantly different than all the other data points that you get, right? There's going to be a lot in the middle, around, $75,000 to $100,000. And you get this one that's, 30 times as much. So what do you do with this outlier? Well, I would argue you should probably keep this one in your data, because there are people who make that much money in Santa Barbara County, right? And Montecito is a rich area. Santa Barbara is a rich area. There are people who just make that much money. So even though it's going to be an outlier, you should keep it in your data for your analysis. Very often, outliers are the most interesting and important points in your data, and throwing them out like misses something really important, right? That's if you're trying to talk about the distribution of incomes in Santa Barbara County, you have to include the really high ones, because otherwise you're missing something really important about Santa Barbara County, which is that a lot of rich people live here. And so, yeah, you're going to get some outliers, right? You're going to get the bulk of your data, like a big mound of data in one place, around $75,000 a year. And you're going to get one or two that are like ridiculously high. And you should keep them in because that's relevant. So let me recommend a book. Do I have it right here? I think I have it. Yeah, I do. It's sitting on my bookshelf, literally right next to me. This book. I don't know if you can see that. It's called Outliers. It's by one of my favorite authors, Malcolm Gladwell. He is a wonderful author, and that book is one of the best books I've ever read. It is all about people who are different in some extraordinary way. Like, it opens with professional hockey players, right? To become a professional hockey player, you have to be incredibly good at hockey. There's, lots of people play hockey. Very, very few become pros, like especially NHL pros. Like, there are other leagues, but the NHL is the best one. And so to get into the NHL, you have to be incredibly good. Like, you're probably talking about the best of the best in junior hockey and best of the best in high school and college. And, there's this weeding out process where, millions of people play junior hockey, but only like hundreds of thousands of them go on to play high school hockey. And only maybe thousands of them go on to play college hockey. And then after that, there's less than 1,000 players in the NHL. So even getting that high, like, you get weeded out by so much that you have to be the very, very best to make it. Right. And so that person who, like, everybody who makes it that far is an outlier. They were incredibly different, and in this case better, than the people they were competing with. And the whole book is about that. It's about what makes people exceptional in some way or other. And it's a great book. I would recommend reading it. It's very famous, by the way. It's the source, not exactly the source, but the popularizer of the 10,000 hours to excellence kind of rule of thumb. So that's really what to do with outliers. Everything's context dependent. An outlier is just an unusual data point. When you see one, you should, there's one thing you should always do with outliers, which is investigate further, right? Figure out, is this a thing that I want to keep in my data or not, and why, right? And if you have a good reason to keep it in, then keep it in. If you have a good reason to throw it out, then throw it out, but don't make the decision randomly or capriciously, right? Make it thoughtfully and decide every time, do I prefer to keep this in and why? Do I prefer to throw this out and why? Right? There's always an and why. There's no default setting here. So that's what outliers are. There are things that are way different than other things in your data set, other things that you're studying. And there's two methods that we use to find them. No, that's not really true. There's two methods to find them. One of them, the 1.5 times IQR that I spent all this time explaining, is the method that I'm not all that interested in using. It's complicated. If you ever see it in another class, this is what it is, but I'm not going to use it. The one I prefer is 2S. Anything more than 2S away from the mean is an outlier. That's what I'm going to use as my definition of outliers. It is, like, you can see that it's functionally a little bit different, but in practice, most points that would be outliers in the 2S method would also be outliers in the 1.5 times IQR method. So I say, let's just use the easy one if they're pretty much the same. So that's what we're going to do. And then the thing that you do with outliers in your data is decide if you want to keep them, and make that decision thoughtfully and with some sort of reason behind it. And that is all I want to say about outliers. So I will go ahead and, that wasn't the right place. I'll go ahead and stop the video here. I will see you guys in the next video.